Okay, it looks like it's working.
Yeah, thank you for joining us our lunch and learn today. This is our last lunch and learn for this semester. So we are joined by Joseph from Adex, Architecture Coatings. So like he said, if you guys ever have any question, feel free to leave it in the chat. Yeah, if you are ready, please go ahead, Joseph. Thank you.
Okay, thank you, Chu-Young. So just want to introduce myself as well. Like, my name is Joseph, but I go by Joe. You guys can refer to me as Joe, that's fine. I'm a CTR, that's Certified Technical Rep with Adex Systems. I've been doing this for 5 years with Adex, but I've been in this industry for 8. I used to represent a different product before. And prior to this, for 23 years, I was a technical rep for paint coatings, selling industrial and architectural paint coatings. So it was a nice segue to come to the acrylic stucco side, because to me, the acrylic stucco finish is like paint with aggregate in it. And it's just take a lot of my knowledge from my past experiences in paint coatings into this field. And I'm very passionate about it. I'm based out of Edmonton, but I travel across Western Canada doing these presentations. I'm also a member of the CSC Edmonton Executive Committee, and I've been doing that for about 4 years now. I'm going to give you a brief introduction to our company. So Adex is a Canadian EIFS manufacturing company. We manufacture out of Quebec, and our head office is in Montreal. These 5 stars that you see here, or sorry, 6 stars that you see here, are our corporate distribution centers, or large distribution centers. We have one there in Calgary as well that services pretty much all of Western Canada from there. This is one of the things that we do differently, because it's the way we bring our product to market. We sell direct, but at the same time, we have distributing partners represented by these circles. You can see we're covered right across the country. So we're a national company. We sell our products from coast to coast. We have lots of employees of Canadians in our company, plus indirectly and directly. We make products for typically 3 types of wall systems. So the direct applied is pretty self-explanatory. When you've got an existing building that was done, older building with some type of either cement block or brick or whatnot, you want to give it a more modern look. We've got the materials to do that, but it doesn't add any thermal benefit whatsoever. We're not adding any foam to that situation. The cavity wall in the middle, that's a pretty standard type of system that you'll see with other claddings like metal panels or longboards. In this case, what we do is we use a cement board to close off the opening, and then we finish it with acrylic stucco. There's some pros and there's some cons to this type of system. Some of the pros are that it's non-combustible, it's very high in impact resistance. Some of the pros or the cons are that it's heavy, and there are a lot of thermal bridging here with those girts. I mean, you could use clips and other means of attachment, but it gets expensive too. And then there's EIFS, and EIFS stands for Exterior Insulated Finish Systems. And there's many different types of EIFS systems, and it largely depends upon what type of foam you're using. The most common foam is a type 1 expanded polystyrene, which is called EPS. And like I said, we've got many systems. Today, we're going to focus on the most commonly used system, which is called our S system. And we'll introduce that in a moment. Now, if you were to go to our website, to save time, I'm not going to take you there today, but if you were to go to our website at adex.ca and you look up any one of our systems and scroll down to the bottom of the page, this is what it would look like. They all look the same. And we've got our system specification there. We've also got it in a Word format so that you could take it for you future spec writers. You might want to augment it, like you could make it as generic as you like, or you could cut and paste, you can add things to it. We make it very easy for you. Also, we have our warranty, a maintenance guide, and then we have these files, the Revit and AutoCAD files at the bottom, where we actually have for you future architects. We've got drawings already done with steel stud and wood studs that you can import into these systems to save you some time. And then on the right-hand side here, we have some PDF technical drawings. I'm just going to give you an example of one of them. So these are like the most common ways that we would do these terminations or connections in our systems with other claddings or with flashings or whatever it might be. These are just suggestions. They're the most common way, but they're not the only way. We're not that rigid a company to say, you have to do it this way. Oftentimes contractors will use these as shop drawings because they don't have the means of creating their own shop drawing. So this is our agenda today. We're going to introduce you to our RS system. The RS stands for rain screen. It has geometrics in it, which allow for better drainage. I like to refer to this system as the really sexy system. And you'll see why when we get into the third part, because of the aesthetics. We use this basic RS system, and then we finish it with many different ways, even ways other than with acrylic stucco, as you're going to see. And in the middle, we're going to talk about energy efficiency and how EIFS can help you to meet NECB and Passivhaus requirements. And then, of course, the aesthetics, the sexy part. We're going to get into that too. So let's get right into it here. We're going to give you an overview of the RS system. I mean, basically, what you're going to have some type of a membrane. We make multiple different membranes. Some are permeable, some are non-permeable, some are like a copolymer rubber, some are cementitious. So we make a number of different membranes. And then you're going to have the foam, typically EPS, that's the most common, with the grooves, with the geometrics in the back, continuous insulation, and then you're going to have some sort of a finish coat on the surface. We are tested to lots of different standards. We're a highly tested system. CCMC, we're tested to evaluated. It's a 17-page document. It talks about wind loads, drainage, and lots of different things on that document. Of course, we passed that. And then there's the fire resistance, the fire standards like Cannual CS 134. There's also 101. There's different standards, which we comply to with up to 6 inches of type 1 EPS insulation. You see, the insulation, this foam, is combustible. But in the building code, there's many code relaxations where you can use combustible materials in a non-combustible wall assembly, provided they've been tested to Cannual CS 134, which we have. And we are also complied to the standards Cannual CS 716, which there's 3 different standards there, which we comply to all of them, which is basically the heart of the building code when it comes to EIFS in the National Building Code. So I want to just take this moment to show you some projects we've done in the past, which won some awards. This particular project here was done in Quebec, and it was featured on the Canadian Architect magazine back in April 2019, which it's rare that EIFS is even featured in this magazine, let alone on the cover page. But just to give you an example of how EIFS is, it's a very lightweight and very shapeable type of material. So many styles can be done. You saw that there was like sort of a circular. We've got ways of giving you multiple cladding looks as well. This is a project just interesting here. This one was in Edmonton, and I was involved in this project. Signature 1 and 2 that you see in the picture here were done under the old energy code. So they only required they added only have 2 inches of insulation on the exterior, and then everything's batted on the inside. But the energy code changed when they built Signature 3, which is just peeking out of the right top corner there. That's a 12-story tower. And it was deemed more economical and much easier to actually insulate this one completely outbound. It has 5 inches of insulation on the outside, nothing in the cavity. So it has a vapor barrier. The other 2 have an air barrier. This one has a vapor barrier. And that is becoming more and more common now, to finish buildings like that. Just a couple of projects too to show you that there's no limit in height. We've done many tall high rises across Canada. These 2 were in Edmonton. We've done 39 stories tall. These 2 are in Calgary, the Sasso and Vitro Towers. And here's another award-winning project that we won for energy efficiency. So with the RS system, we're depicting here 8 different steps, but in reality, there's 10 steps. And what we're not depicting here, what's missing is there should be a flashing at the bottom of that wall, metal flashing, and there should be caulking and sealants. And we don't really depict or discuss those because we don't manufacture them. So we left them out of the presentation. It's going to save some time as well too, but they should be there. So really there's 10 steps. Now, the way this breaks down is the first 4 steps here are all about providing you your substrate, like to have air, stop your air from leaking or vapor transmission, and to give you thermal benefit. The next 4 are all about protecting that insulation from things like impact, fire, and then of course giving you the aesthetics. So what we're going to do today is we're going to talk about the first 4, then we're going to have a quick break for some questions, then we're going to talk about the energy efficiency, and we're going to talk about NECB and Passivhaus, and then we're going to have some questions, and then we're going to talk about the next 4 and final question period. So let's begin. Transition membranes are the first step. And there's lots of transition membranes on the market, but what they do is they provide weak links. They protect the weak links of the building, all your openings, all your penetrations, and they provide a compatible surface for our membranes to come over top. And like I said, there's many different types. We find that the best transition membranes would be the ones that have a bit of a nap to them or hair. like an SBS membrane, it has fabric. We call these EIFS tape. This one is used in conjunction with a primer, much like the way contact cement works. It promotes good adhesion. Then there's on the far right-hand side, there's self-adhered ones, which do not require the primer. They too have a fabric on them. And then the one in the middle is an STP polyurethane, which is like a caulking, a very mastic caulking. It's a moisture cure, so it likes a wet surface, or it can be applied in the rain. If it's a super hot day, you should mist it with some water to get the curing to start, because it needs the moisture. And this is great for doing geometrics like circles, like pipes, even like I-beams that come out of a wall in a strange angle. You could do anything you can do with a transition tape, you can do with this material too. But most EIFS applicators just use it for the tougher geometrics. The second step would be the weather or water resistive barrier. Depending on your building or your wall assembly, it may be permeable or it may be non-permeable. The most commonly used ones are these copolymer rubber types. And we're going to talk about that in a moment, but this is the next step. And as you can see these depictions here, sequencing is important in my view. And so from the far top right picture, you see the joints, the sheeting joints were dealt with, and around all of the penetrations, the window openings, door openings, they're dealt with first. Then the membrane is applied to the proper thickness over the entire building and wrapped. It gives you a monolithic, almost like a paint coating, there's no reverse lapse or anything like that. And quite frankly, this material could be used under all claddings. It's not just a membrane that's solely for EIFS. It could be used under all claddings. But you'll get pushback in the real world from other trades. They don't want to lose their scope of work. And the issues are always come in the connections. Like when you're one scope of work, say it's a brick or metal panel or whatever, and then you're putting some EIFS next to it, there's a transition there. And that's where always these issues kind of come in if they're not done properly. But if you wrap the whole building with one membrane, you don't have to worry about those issues. The membrane does seal screws, so it's not an issue there. And this particular membrane can be sprayed as well as troweled or rolled, as you see in this video clip. Obviously it was a nice day, no wind, there was no glass in the windows. Often when we're doing this, there's already windows installed, so they'd have to be protected. And of course, this applicator, as you can see, is taking care of all the sheeting joints first and the transitions. They would be checking the thickness with a wet mill gauge periodically to make sure they're applying it thick enough as well. This red material that we've been showing you here is called our Hydroflex WO. At Adex, all of our membranes have the name Hydroflex, and then the digits afterwards, or like the last name of the product, is depicts kind of what it was intended for. So the WO actually stood for wood, but I think we made a mistake when we named this. We should have probably called it UN, because it's very universal. It goes on wood, it goes on fiber mat board, it goes on concrete. It bonds really good to metal as well. So it's a very universal product. And like I say, it's a copolymer rubber type of material, and it can be applied by spray, trowel, or roller. It performs 30 times better than what the National Building Code requires for an air barrier. And this is key when it comes to talking about energy efficiency later. You really need a tight seal. That's even more important if you can wrap your head around that. Having a tight air seal is more important than actually having thicker insulation. You'll get more benefit from a tighter air seal than from thicker insulation. So the cousin is our Hydroflex Vb, and the Vb stands for vapor barrier. It's a dye difference, so we can see the difference in color, but it's not the same material. It's not like we just dyed it and say, put it on twice as thick. No, it's totally designed differently. It doesn't spray at all, and it doesn't roll very well. It's really a trowel on. And quite frankly, whenever you're putting membranes on wood, we really recommend that you do trowel it on, because the troweling gets it on heavier and pushes the material in and fills all those voids and defects in the wood. It fills the screw holes better and all that. So I always recommend, at least like with the other one, with the red material, one trowel and then one roller, but never just two rollers. I don't like that. The next step in this first phase is putting on the insulation itself. And like I said, because it's the RS system, it uses a geometrically designed grooved out of the back, which is now in the Alberta Building Code 2019 AE edition for Part 9 residential construction. It is mandatory to use grooved insulation, not flat. And you can see from the depiction here, there's those 3 lines of gray just on the other side of the foam. That's the cementitious adhesive base coat that's holding it in place. We don't use mechanical fasteners for this system. That same material is what's used on the surface here when we're embedding the mesh that's coming up. Our pattern, this picture makes it look like an egg carton, but really it's diamond shaped. And I've got a better picture I can show you at the end of the presentation. But this diamond shaped pattern that we have is really liked by contractors because it limits the waste, because you can install this horizontally, vertically, diagonally, however you want, and the drainage never gets blocked. And we still meet this minimum 13% that's required by the standard, the Canyon C S716 standards. You have the drainage plane must be at least 13% of the back of the foam, if or greater. If you take some of our competitors' foams that have vertical channels, if they're cut, like the board itself, it meets the minimum, but if you cut it and take a small piece, it may no longer meet the minimum. And the other thing about vertical design is if the contractor installs it the wrong way, for example, they're supposed to install it horizontally, but if they install it vertically, now all the drainage channels run the wrong way and they effectively don't work. But with our design, you never block the drainage. Minimum thickness is 2 inches, because if you cut a reveal in there, an aesthetic reveal out of the front, it has a 10 millimeter cut out the back, you wouldn't have enough insulation to support that joint and it would crack in that reveal. So 2 inches is the minimum thickness required. So when it comes to thermal bridging, thermal bridging can be caused by many things. Mechanical fasteners are just one of them. And depending on what's causing the thermal bridging, it can be quite severe, and you could lose up to 30% of the effective R value. So by eliminating the mechanical fasteners, we help to eliminate thermal bridging. The other thing is we displace the dew point as we insulate further and further outside of the wall. That keeps the inside of the wall dry. And so like I said earlier, lots of projects now are starting to insulate 100% on the outside and nothing in the batting whatsoever. Here's some projects of depicting exactly what I just said. You can see their green vapor barrier was used, and then the foam was installed. It's much thicker foam. Like these projects, some of them were 6 inches thick, some were 5 inches thick, and nothing in the cavity whatsoever. The nice thing about this is that it's one applicator who does it all, and the vapor barrier is dry and can be inspected to make sure there's no defects in it before the foam gets installed. Some of our competition, what they do is they say you're gonna actually adhere the foam into wet membrane. Now, if you do that, then you have no opportunity to actually inspect the membrane to know whether or not it was installed properly and is thick enough. But we don't believe in that. So what we do is we make sure that our membrane goes on and is dried, and then we put the vertical ribbons of adhesive onto the wall, and then we adhere our foam. As I mentioned before, we're going to eliminate condensation risk by insulating further and further outside, the dew points on the outside, and potentially we can increase the net floor area of the interior of the building, which is what your clients really are making their money on. They're either selling the building or renting the building based on interior square footage. Now, how do we reduce this? How do we increase that space? Well, if we were talking about a passive house job here, perhaps you might actually require a 10-inch thick wall cavity. But if we insulate on the outside, the further we insulate on the outside, we can reduce that 10-inch thick wall cavity to perhaps 6 inches. Now we've just increased an extra 4 inches all around the perimeter of the building. It sounds like minimal amount, but it actually adds up to a lot of square footage, especially if we're talking about a high rise. So that being said, that part of the presentation is over, and we're going to get into the energy part. Is there any questions on what I presented so far? Nothing? Okay. Nobody has a question. I'm going to continue then. So now we're going to talk about the envelope optimization and NECB and Passivhaus. And again, the key to meeting these requirements is really air, that we have a tight building. Let's take a look at the NECB and how it was adopted in Canada so far. And you can see here, Alberta adopted it in 2017. But some parts of the country, especially Eastern Canada, is lagging behind and have not actually adopted this principle yet. Now, with the NECB comes three different paths, compliance paths: the prescriptive, the trade-off, and the performance. Now, as you can see from the meter on the right-hand side, we feel the prescriptive path is the easiest, but a lot of buildings require the performance path, because you might have a lot of glass and curtain wall. Imagine if you're in Vancouver and you're doing a high rise, you couldn't follow the prescriptive path because you wouldn't have enough window openings. People wouldn't want to live in those apartments. They want to see the view and the vista. So performance is the most widely used, but it's more complicated to explain in the time we have today. So we're going to focus on the prescriptive path. It's just an easier, straightforward path. You require a certain U value or R value. There's a percentage of allowable fenestrations for openings, and this is depending on what climate zone you're in, and air leakage requirements. So the country is broken down into different climatic zones. And so we are in the 7A, 7B zone. And that's determined by how many heating degree days are required. So for example, if you can think that, how many days in a year does your furnace need to kick on to heat your room to room temperature? And then that's how they divided this. And so as you can see by the map, a good chunk is in the 7A, 7B zone, but then there's the Arctic there where they're in zone 8 and require more insulation. So we need R27, an R value of R27, and a U value of 0.210. And the U value is the total wall assembly, all combined, not just the insulation, but everything combined. And so that question mark there is, what would the minimum amount of type 1 EPS insulation be? How much thickness? What's the thickness required in order to meet this compliance path, prescriptive path in all zones? Now, I apologize for the small font here. And if anybody actually wants this table, you can just email me and I'm willing to share this with you, along with all the math that we used to compile this. What we did here was we took the ASHRAE Handbook of Fundamentals and we took all the R values that are associated with all the construction materials. And then we designed walls that are either steel stud or wood studded and have 24-inch centers or 16-inch centers, and whether it's insulated in the cavity wall or not insulated. And we came up with the minimum amount of type 1 EPS. I also have this for a foam that's called GEPS. And GEPS is also a type 1 foam, but the difference is that G stands for graphite. It uses a graphite bead. So it's not white insulation, it's charcoal in color, and it adds about a whole R value more. So the R value of type 1 is based on at room temperature is 3.85 R per inch. And the GEPS is 4.7. So it's nearly an extra R value per inch. It comes at a premium price. It comes at about 40% higher in cost though. Now, this would be the worst case scenario on all that is if you were building something with a 2x4 metal stud in our temperature zone, and you had spacings of 24 inches on center. If it was insulated, 4.5 inches of type 1 would be required on the exterior. If it was uninsulated, 6 inches. If you had 16 inches on center, you've got more thermal break, or more thermal bridging. So you would expect an uptick in insulation requirement. There's a small uptick. It's 5 inches thick if it's insulated and 6 inches thick if it's uninsulated. Now, let's talk about Passivhaus for a moment. So Passivhaus is an energy standard that came to us from Germany, and it's pretty intense. It's really just about reducing consumption. It's unlike net zero, where net zero is a balancing act between reducing consumption, but also creating energy and putting it back into the grid. With Passivhaus, it's all about reducing consumption. And in British Columbia, they're looking at introducing this to having all their buildings meet Passivhaus standard by 2032, which is going to be a good challenge because of, like I said, all those glass high rises. Like when I'm talking about new construction, I'm not talking about existing buildings, but they're still going to want to build some high rises. Now, this information I'm going to share with you here came from this Canadian Housing Mortgage Corporation, and they published an article back in 2017, which said the average Canadian home was 1,900 square feet in size, and it consumed 20,000 kilowatts per year for heating and cooling solely, not running TVs and refrigerators and all that, but just for heating and cooling. They call this a TEDI, and the TEDI stands for thermal energy demand intensity. And so broken down, that works out to 115 kilowatts per square meter per year of energy consumed for heating and cooling purposes. And they noted that the air tightness in the average home was over 5 times at 50 pascals. And so what that means, if you think about the room that you're in right now, if you had to pay to either heat or cool that air in that room 5 times in an hour, you could realize that that's going to start to add up quite a bit. You've got a leaky home, and where's that air going? It's just going through cracks and crevices, and it's escaping. It's escaping to the exterior. So you're consuming lots of energy and trying to heat the space or cool it in the summertime, and it's leaking through. And so the whole idea of Passivhaus was to reduce that by 90%. They want to have a TEDI of 15 kilowatts per square meter per year, and they want to have an air tightness of 0.6. So it's quite a tight design. And with that, there would be changes to HVAC as well, so that we're continuing to breathe nice, clean air and the air doesn't become stagnant. But I'm not an HVAC guy. We're not going to talk about all the improvements to HVAC that's required, but we're just going to talk about this passive house and how it relates to EIFS. And so I'm going to share with you a couple of different projects that we did that are certified passive house projects. And this one is in Vancouver. Keep in mind, they're in a different temperature zone. They're in a warmer zone. This particular project is passive house certified. It met with 15 TEDI and a 0.477 air exchange. It has EIFS, as you can see from the rendering, acrylic stucco and EIFS around most of the home, and then it has some wood siding there as well. Now, this is the way the walls looked from the outside. It was sheeted with plywood, and then our Hydroflex WO membrane, our air barrier, was applied. Of course, it was tested and blown, and that's how we know we got the 0.47. All the rough openings, all the penetrations were sealed up properly. Now, the wall itself, how is it constructed? Well, the interior of the wall actually is a double wall construction. It uses wood studs. They were 24 on center, and there's mineral wool insulation in between. That thickness is on each of those walls is 4 inches. So that's 8 inches of mineral wool on the inside. Mineral wool is a very expensive insulation. It's twice the price of EPS, by the way. We do use mineral wool in our EIFS systems on the exterior when we need a non-combustible system. You know, today's presentation, I really didn't talk about all the different systems we have, but we have non-combustible systems too. We'd substitute the EPS with mineral wool. And then what happened after on the outside, the plywood sheeting, then our Hydroflex WO, and then we added an additional 5 inches of GD insulation type 1. So that's, as you can see, that's a well insulated wall. It's got 8 inches of mineral wool on the inside, 5 inches of EPS on the outside. It's a very expensive wall as well, but we didn't design it. I mean, B2 Architecture designed it, but this was in the infancy here, and not a lot was known about passive house yet. We're just trying to figure it out. And here's an example of a passive house by accident project. Okay, this is the radius, and it's in Pemberton, BC, which is in the same climate zone, but it's about 165 kilometers north of Vancouver. And so this is a rental property. This is an apartment building. And the owner, he thought in his mind, no way I want to build a passive house building because it's going to be way too expensive. So he just wanted to build a high energy efficient building to keep his utility costs down. But it turned out by accident, he achieved a TEDI of 8, which was even better than the TEDI achieved by the other project. And he was certified passive house on this project. It had the air leakage met the requirement, and it was done a lot less expensive. It was done with 6 inches of EPS insulation on the exterior. A vapor barrier was put on instead of an air barrier, and there's still insulation in the batting, but it's only 6 inches. And you can see there's only one wall. It's not a double framed wall. So there's a lot of cost savings here on this build, and yet it still met passive house. Now, I'm not suggesting we could do it like this in our climate zone, because it all depends on where the dew point is going to be. If the dew point is on the exterior side, yeah, we can do this. But in our climate zone, I would suggest not. I would suggest that we need to have more insulation on the outside, or less on the inside. We might need to have an air barrier instead of a vapor barrier, because of where the dew point is going to be. So before I move on to the aesthetic part of the presentation, any questions on that? On the energy efficiency? No, I just wanted to show that, we can help. EIFS is a way of helping achieve those codes. We're not saying, it's the only way, but definitely EIFS is a solution to the problem. And now we're going to talk about the next 4 steps, and we're going to protect that insulation. So we need to, I'm depicting here in this picture, we're going to protect it from impact or fire, and then we're going to give you aesthetic finish. So the first step would be what we call the lamina. And the lamina is the base coated mesh. And then this mesh is treated for alkaline resistance. We make different meshes. This is called standard mesh. The weight of it is 4.5 ounces per square meter. And we embed it in our non-combustible base coat that's made to a Cannuel CS 114 standard. And this is a polymer cementitious. This is the same material that we actually adhere the foam with. And to meet those non-combustible standards like Cannuel CS 134, what has to be done is anywhere where the foam is not touching another piece of foam. So like at the top of the wall, bottom of the wall, where it might need another material, like might need stone or metal cladding or something, where it wraps around a window or door, or if something's coming out of the wall, a pipe, a vent, anything, sprinkler head. Wherever the foam doesn't touch another piece of foam has to be what's called back wrapped. And that's where you take this mesh and base coat along the edge of the foam and around the back side, the side we don't see, 3 inches. And that's called back wrapping. And that's what's required in order for it to give the time for fire crews to come and douse the flames, and for people to escape a building that might be on fire, because the material EPS is combustible. It doesn't ignite, like it doesn't burn like a big flame, but what it does is it gets hot, it melts, it kind of turns into a soupy hot lava, which could add to the fire, could start other things on fire, but it also impedes rescuers from coming and people from fleeing a fire. So the back wrapping is what's holding it in place for about 20 minutes for fire crews to come and for people to flee. Now, if the lamina, if I had a sample, if we were in person, you'd see it's quite thin. This 4.5 ounce mesh and base coat is quite thin. So if you wanted to protect against impacts like, say, shopping carts and snow shovels and wheelchairs and things like that, you wanted extra protection. The typical way of doing that is to reinforce it with thicker meshes. So you would use a heavier mesh first and then the lighter mesh on top. Both of them are embedded in base coat, so it gives you a thicker base coat and gives you a much stiffer, stronger mesh. We make all the way from 4.5 ounces to our armor mat mesh goes up to 15. So together, that's 19.5 ounces of mesh, plus all the base coat that's in between. And that works great for that type of impact. But one thing it doesn't work good for is some birds, like the woodpecker, for example. Some other birds as well that will like to burrow into EIFS. The woodpecker is the biggest of the bird and it hits the hardest. And so we designed a system to be woodpecker proof. Okay. And this is called graphics coat. Now, this is a base coat that is reinforced with graphene fibers, and graphene is a derivative of graphite. Graphite is 22 times stronger than steel. So this is a really hard surface. And as you can see from this depiction here, as you can see from the very left-hand side of it, let's say you had a building that already had damage with EIFS, and you can see how thin that 4.5 ounce mesh and EIFS system is on top of that foam. It's quite thin. So birds that like to peck holes in there, they get through that pretty easily. But then these 2 gray bands that come along the middle there, that's the graphics coat. And so graphics coat comes in 2 parts, an A and a B. They're exactly the same material, but A has a stone in it, which is used as a mill gauge to let the contractor, the applicator, know how thick to put it on. If you try to apply it too thin, you'd get a scroll mark in there like a worm went through it, which would telegraph through the finish and be undesirable to have that. So you apply it as thinly as you can, but yet eliminate the scrolling. We call it scrolling with that worm, that stone's moving around. And then you put on the B, which is the same material, but without the stone, nice and smooth, level it all out. Then you'd prime and finish. The depiction on the far end of that would be if you were doing new construction, you'd bring it to the base coated mesh, then you'd add the 2 steps of graphics coat, and then you would finish it. So this graphics coat, we offer a warranty of 10 years, including labor. So your clients would be protected from any bird damage whatsoever for 10 years. If there's a hole made in that system, Adex would pay 100% for the repair, materials, and labor. Here's a video clip of us hammering it pretty hard with a hammer in the same spot. We broke it off the back of the sampler, but we didn't actually crack or really damage the finish whatsoever. It takes a really good force. We've developed this to withstand 3 times the Newton force of a strike of a woodpecker. I could talk about this product for an hour straight, and all the research and development went into it. But trust me when I tell you, we know that we're never going to have to pay that claim. Now, our acrylic finishes, we make all kinds. They come in all different colors. We make from a really smooth, like baby smooth, like drywall, level 5 drywall finish smooth. It's called Sonora. We start increasing with aggregates like to a 1.0 fine, like Sienna. We have a 1.5, like a Madero or a Monaco in the medium, and then we have a 2.0, like the stone is bigger, so give you a coarser texture. So we make all kinds of different styles. Some have the scroll mark in it, but acrylic stucco was kind of boring, you know, to be honest with you. Like they all look the same after a while. So I like to talk about the sexy part now. You know, the really sexy system. It's these unique specialty finishes which we could use to really give EIFS a lot of pizzazz. And so the first one I'm going to talk to you about here is called crystal. And crystal is like a paint coating. It's a metallic paint coating, very glossy, very shiny. And you would apply this over top of any EIFS acrylic texture. In this case, it was applied over a medium one here. And this is a bit magnified too, but it could have been applied over Sonora, which is super smooth to mimic a metal panel. We can do that at a lot less expense than what a real cost of a metal panel is. And I've got some depictions of that here. This is a project we did in Calgary, as you guys are all in Calgary, and this is not all that far away from you. It's kind of like 12th Ave, I think, Southwest, downtown. It's called the Arc. And this was done before we made Sonora. So we used a product called Sienna, which has a little bit of texture. And then the crystal coat, the red and the blue bands up the stripe of the buildings here were painted on by roller on top of the EIFS. And the reason that this was done was this was initially supposed to be metal panels, but they had a hiccup in manufacturing. They couldn't supply in time. So the general contractor asked for an alternative, came to us. We said, let's give you like the RS system. This is our RS system with this crystal coat. And it still looks pretty good today. You know, it does fade, like everything fades, even metal panel fades. Everything fades in time. We use the best pigments we can to sort of resist fade. But at the end of the day, all that would be required would be another coat of crystal coat just to freshen it up. And so it's a quick fix. Unlike if it was a metal panel, which had faded it down, you'd have to replace that metal. And that's a lot more expensive to do than putting another coat of crystal on there. Here's a specialty finish that we make that's called Micatex. And Micatex uses these polychromes, these multicolored flecks, these aggregates, and then it uses a mica flake, which is like, looks like a diamond. And when the sun catches it, it just pierces out at you. It's like a diamond shining. And we make the exact same product called plastine without the mica flake, so it doesn't have that piercing of the diamond. So you'd use plastine if you were trying to mimic more of a stone block or even brick. You'd use plastine versus Micatex. Now with Micatex, here's an example of it on the use on the outside of a building. Just adds a little bit more pizzazz than, you know, if it was just like a black acrylic stucco. But we're using a lot more of this interior now. A lot of interior designers are starting to use acrylic textures, and Micatex is starting to be used more and more indoors. This is a really unique system called the ABS system. It stands for adhered brick and stone. We could have put a T on the end of that too and called it tile, because we have done some projects where we've adhered tiles. And this is a very high energy efficiency look. It gives your clients an option here so that you can clad in stone or brick veneers. And to the person on the exterior, it looks like it's, you know, solid real stone and brick, but it's a veneer adhered to our RS system. Now, there's a couple of tweaks here. As you can see in the depiction here, this is our RS system like I talked about, except that we don't use a standard 4.5 ounce mesh. We use a thicker intermediate mesh. It's 11 ounces. And then we embed it in the base coat. You'll see there's a washer head underneath that windowsill there. That is a mechanical fastener. So in this system, to help support the weight, we need 2 mechanical fasteners per 2x4 sheet of insulation. And then the stone can be accessed from anywhere. Like, that's the thing. If we forced you to buy stones from Adex, well, we're middlemen and it would just cost more. But we don't do that. We don't get into this veneer game. So you can purchase your brick and stone veneers from anywhere and keeps the cost down. But you have to keep it to a certain weight per square foot. We designed this to go to the 10-foot height mark and support up to 10 pounds per square foot. Keep in mind, there would be a flashing at the bottom of that wall. We discussed that already. Flashing's missing there. So you've got your drainage plane, everything's good. It's totally insulated. It's one membrane, you know. This is a much more energy efficient way to give a client a stone look. Here is a real world depiction. This is the Hyatt Place Hotel in Calgary near the airport. And that is EIFS, that's our RS system on there with this adhered stone. And I've got some nice pictures of this project I could show later. Here's another project in Calgary we did called the London Heritage London. And this has a thick, heavy Tyndall stone on the bottom, about 3 feet or so, 3.5 feet, cap flashing, and then brick veneers all the way up to the 32-foot mark. So how come we're able to go past the 10-foot mark? Well, we've done lots of projects past the 10-foot mark, but they have to be engineered by a third party to say how many more mechanical fasteners or what other form of support is required to support the weight. We don't get involved in that. We've only engineered it to the 10-foot mark, and then that's it. Outside of that, you have to get another engineering firm or do it yourself to look at what would be required. Now, the building behind, that's a tall building, and it has a brick look to it, but we couldn't be done this way because of the height. It uses a stencil, which we call Bricktext. So Bricktext is a number of different brick stencils or stone stencils, and they can be done, they have different shapes, and they can be done in many different ways. They can even be painted like this to look old-fashioned, and they can be, this is a stone look with the plastine. Picture doesn't do it justice. This actually looks beautiful, like in real life. But a lot lightweight, a lot less expensive, quickly done, insulated. We've taken that whole concept of stencils one step further at Adex, and this is unique to Adex. We've come up with this program called Stencilix, which allows you, the creative people, the design people, to make your own stencils. Now, there are some parameters as to how to go about this. It's on our website under Stencilix, and it gives you this parameter. So you would create your own stencil, you'd send it to us, we'd peruse it and say, yep, this would work, we can create the stencil. And then you'd give us a square footage and say, I need, like, whatever it is, 1,000 square feet of this. And then we can pretty much give you an estimated cost of what it would cost to do that. And so here's an example of if this is a Part 9 nice custom home, and then you created a nice custom stencil that doesn't look like brick or stone. It looks different, and it's popped on. It gives you a nice pizzazz. Here, it was used interior, like with paint or with acrylic stucco too. It could be either or, but you could use these stencils inside. Here's a quick video clip of us actually installing a stencil. So this is one of our field tech reps out of Calgary. His name is Bill MD. And so you would have our base coated mesh, the EIFS, the RS system to the base coated mesh. You would prime whatever color you want the mortar to look like. You would prime that. In this case, it's that gray color. The stencil gets adhered over top. Then you apply your acrylic stucco and remove the stencil while the acrylic stucco is still wet. This gives you a nice, crisp, clean line, and the stencils don't break apart or become difficult to remove. These stencils only have a one-use application. They cannot be reused. So you join it by keeping a wet edge. So you just continue and go. Anybody that's done a brick stencil or stone stencil, the concept is the same. And look at that, gives a lot more sexiness and pizzazz than, for example, if it was only just a navy blue acrylic stucco. This is a way of really, and you could put your own stamp on this because you could create your own stencil design that is unique to your firm. Like, so it's like you would almost recognize immediately, oh, that's so-and-so architectural company because that's the same stencil they use on every project, right? That is pretty much the conclusion of the presentation today. And I think if I've done my presentation well, I've shown you the versatility of EIFS and how it's lightweight and cost effective, and how Adex is a national company. We like to help with master specifications as well. And we could provide a list of qualified EIFS applicators in the area so that your clients can maybe just private invite the right ones instead of getting all these like lowballers or guys that are unqualified pricing. And we can be there for pre-construction meetings too. Now, before I leave you today, I'm going to leave you with a bit of a chuckle. And then, of course, I've got a lot of pictures here that I could share, and we can have some question period because we still have about 10 minutes left. This is the typical process of a project. And this is what we kind of try to avoid happening because we need a good communication in order to this not to happen. But this happens far too often, unfortunately. So in the future, when you're in your firms, one of your clients will come and have an idea for a project that they want to build, and then they'll present their budget. There's something missing in this here. Obviously, what they're asking for in the budget doesn't add up. But you do your best, as your architectural firm will do their best, to come up with what you think they are asking you for. And then our wonderful trades out there, our general contractors and our subcontractors, will try to decipher your hieroglyphics, and build what they think you are asking them to build. And of course, your client has in their mind what is being built, and they're promoting it hard to get some pre-sales, and they're saying, look, this is what's going to be built here, guys, come and buy. And sometimes during the process, you refer to the documentation, and it might be a little bit cloudy because perhaps someone hasn't really been keeping up to current standards, and there've been a lot of cutting and pasting of specifications, and they're not as current as they should be. And so there's some cloudiness in there. Inauguration day comes and it's not quite what was anticipated. And of course, you provide the bill to your client and they feel like they were taken on some real scary roller coaster ride, because it's like, oh, what do I do? It's not quite what I wanted. And this is what they needed in the first place. And so how we get from A to Z is all about effective communication. And that's where I would say that in your future lives, as you go into the world of architectural design, is try to find yourself a champion in every field. Someone that you trust. They should be a CTR, because as a certified technical rep, they really are required to be very honest and straightforward. And if you have a champion that you can trust in every field, get their expert advice as to which one of their systems are best for cost or for just usage and everything. And hopefully with good communication, you avoid the process. Anyways, thank you for your time today. I appreciate it. Again, don't hesitate to reach out if you wanted any more information whatsoever. And like I said, before I leave you today, if you wanted to, I could share with you some wonderful pictures of projects that we've done in the past. By the way, this is the way our back of our foam actually looks like. It's a diamond shape pattern, as I said. And what you're seeing here on the edge this is that back wrapping. Now, keep in mind, this is not completed, because you see how we can still see the color of the red mesh? That should be. We should have all of the color covered. Now, we could still have the pattern of the mesh. That's okay, but not to see any color. Once we see color, we know it's too thin. So this was only one coat application here. It wasn't finished. I just took this picture because I wanted to have a picture of how a back wrap looks like. I didn't wait for it to finish. It was in Calgary. I'm from Edmonton, remember? This was that project, that Hyatt Place Hotel, and it's our ABS system adhered. So you can see it has our WO membrane, the foam was adhered, extra mechanical fasteners, and then the stone was adhered to it. This was that London project, London Heritage. This is the finished project, but this is under construction. And you can see it was using a heavier Tyndall stone, some brick veneers were adhered. There's some acrylic stucco, there's a little bit of metal panel too, but it was all one membrane, all insulated and adhered to the foam. It's a very good high energy build. Does anyone have any questions before I let you go today on anything I presented so far?
Yeah, I'm not sure if you can see in the chat or not, but there's a question.
No, I can't see the chat. Sorry, I cannot see the chat when I'm in this presentation mode. So,
okay.
Yeah, this is the Stencil X. But if there's a question, just throw them out at me. I'm happy to answer. Just unmute your mic and ask me the question, because I can't see the chat. I'm sorry. This is the brick stencil and the custom-made stencil above. So this is EIFS, but it doesn't look like EIFS because it's not that typical acrylic stucco that you're used to. And it's a wonderful looking, looks like a multi-cladding building. There are some other materials used here. It's not all EIFS, but most of this is EIFS. There's some acrylic stucco here as well. But for the most part, it gives such a much unique sexiness to it, and a lot of pizzazz. The fact that we use the stencils rather than totally just being done with acrylic stucco. If I break out of this presentation and stop sharing my screen, I can see the chat. I will do that in a second. I will do that in one moment here, because I just wanted to show you guys a couple more pictures. I wanted to show you the metal panel like that we could do, how it's smooth, and how this is sprayed on crystal coat onto our Sonora finish. So, we can really mimic a nice metal panel. But if you wanted a little bit of texture, it saves a lot of money. If your client will accept a little bit, like this is coarser, this is a medium, but it could have been fine. And it is a great way to save some money by having just a slight texture. So I'm going to back out of this. I think I've shown you all the pictures I really did want to show you. So yeah, I'm going to stop sharing my screen, and then I can answer some questions here in the chat. All right, I'm back. Where's my chat? Let's see, where's the questions here? Chat, there's some questions. Okay, is this product eco-friendly? And with the graphics code system, if I have an issue in my building with the whole wall, will the whole wall be addressed, or just a small part that has been affected by woodpecker? Okay, good question. So I'll answer this Angel's question with the woodpecker question first. So if you have if you have an EIFS system that has woodpecker damage, it didn't have graphics, but it has woodpecker damage, you could just do the repair of the one hole. However, that's woodpeckers. Like I said, I could talk a whole hour about woodpeckers. They're going to come back and they're going to strike it again and again. So you really should, the highest point of the building for sure. If you're prone to getting bird damage, the highest part should be done entirely with the graphics coat. The cost of that graphics coat is about $5 a square foot addition to the regular cost of EIFS. So if we were talking about Part 9 residential construction with 2 inches of EPS insulation, I know these prices very well. The average, the cost of EIFS properly done should be about $10 a square foot. Then you'd add $5 for everywhere where the graphics coat goes. That $5 cost comes up a lot. It's the same price if you were layering meshes, you know, doing that armor mat mesh, about the same price per square foot, and it's the same cost if you were doing a stencil, like a brick stencil. It adds about $5 a square foot as well. The other question, got to go back to it again. Just 1 second here. Is the product eco-friendly? So the yes and no. And the reason is because we don't use recycled materials, unfortunately. So like if you're looking at for leads and stuff like that, we make our materials as lead friendly as we can, like for VOC emissions and things like that. So to that extent, yes, like most of our products are even water soluble, and they don't pose a lot of risk to the applicator from breathing in, you know, VOCs. They're very low or zero VOCs. The issue when it comes to the greater issue is, you know, the materials can be recycled, but we don't use recycled materials to manufacture them. The materials have to be virgin, like they have to be pure. And that is actually part of the Cannual CS716 that, you know, you can't use recycled foam, for example. It has to be virgin made foam. And to make our acrylic materials, we don't use recycled materials. So unfortunately, when buildings get torn off, when they're not done properly, a lot of that material ends up in the landfill, unfortunately. So they need to be done right the first time. That's the key, get them right. When they're done right the first time, they last a long time. There's a lot of buildings in Europe where EIFS originated in Germany. And there's a lot of buildings after the World War II, after they were rebuilding, you know, they didn't have a lot of material and they needed lighter weight and energy efficient materials in there. EIFS was invented. And there's materials that were right after the war in the 40s and 50s that the buildings are still standing today and they still function very well. Like if they're done well, you get many, many years of life from an EIFS system. If they're done incorrectly, unfortunately, it doesn't last too long because you'll get water intrusion and you'll get mold and rot and, you know, lots of issues. They have to be, those transitions are key. Membrane is key too. Any other questions before I leave you guys today? No? Then I want to thank you all for your time. I hope you got something out of it. I hope you learned something. I really appreciate it. And again, don't hesitate to reach out if you have any further questions. I really appreciate it. Guys, have a great day. We'll see you.
Thank you.
Take care. Good luck in your future endeavors. Good luck to you all.
Thank you.
All right. Take care.
Thank
Bye.
you.